Hello, everybody. My name is Masood Olia, and I'm a faculty here at Wentworth in School of Engineering. And I'm here with another short video related to calculation of or calculating the location of the centroid of unsymmetric shape. So basically, this is a C channel. C shape or channel shape rather, sorry. And then in addition to locating the centroid, I want to also calculate the moment of inertia with respect to the centroidal axis. Okay, so I'm going to actually let go of my camera and I'm going to stop my video and start the process of calculations. So you know that in order to figure out the location of the centroid, you know that obviously by inspection, the centroid would be on this line. So Y bar is what we're looking for, right? And you could see that this is what, as I said, is called a C shape, because if you rotate it, it looks like a C, or it's known as a channel shape. So this is a beam with a cross section like this. So first I want to locate the centroid. So I want to figure out what the Y bar is. So you can do this any way you like, meaning that you could break it into 3 rectangles, like the flange here and kind of like 2 pieces here. Or you could even think of it as a subtraction. So it's totally up to you how you want to do this. Let me remove some of this. So I would think that it's probably better for me to use a subtraction, in other words. I would say that this is like having a rectangle with the dimensions of 6 inches by 10 inch, right? Minus, then I'm going to deduct this piece out of it, right? So I'm talking about taking this piece out of it. So I'm going to go ahead and take this piece out of it. So that's a 5 by, as you could see, 8. Okay. So you know the formula for location of the centroid is Y bar is the first moment of area, which is the summation of YA divided by A. So really don't have to do much. Look, relative to your reference is that what you want to locate the centroid. So the reference being the x-axis here. All right, so the centroid of these guys are where? Right in the middle, right? So, and I want the y coordinate only. So remember, we're subtracting though, okay? So y of this guy is 3, right? Times the area is 6 by 10 is 60 inches squared. And sorry, so this is inches squared, right? Minus the centroid of this guy is 2.5 times the area, which is 5 by 8, 40. And then in the denominator, you have the total area, which is 60 inches squared, right? Minus 40 inches squared. So if you do the calculations here, this should come out to be exactly 4 inches. So basically the centroid, I don't like this line. This is not to scale. So the centroid is, I'm going to draw a blue axis here. Actually, let me remove the all this blue here that I was trying to show you that's what how we're going to subtract, right? So the centroid basically is somewhere here, more or less. All right, so just forget about this guy for a second. So this is where C is, right there. And that's what 4 inches from the reference. Okay, so that was easy. Now, what I want to show you is how you can actually now find the moment of inertia with respect to this blue axis. All right, which is known as the neutral axis. Neutral axis is the point on the beam where the bending stress is equal to 0, and it reaches a maximum on the top or the bottom of the beam. Okay, so the next thing we're going to do is calculation of I with respect to the blue axis, the axis that passes through the centroid. So let me actually go ahead and draw the blue axis here, and of course, Let me actually bring it down a little bit because to be more consistent. Okay, so the blue axis should be 2 inches from the top, right? Let's pick this pen like that. And the same axis here. And then I'm going to use again the process of finding the moment of inertia is with respect to the subtraction rather than addition of pieces. The same way that I found the centroid. All right, guys. So now this is not twisted. Now what I'm going to do, I'm going to draw the axis that passes through the centroid of the individual shapes, right? And that's in the yellow axis. That would be the centroid of each shape. The blue is the centroid of the composite shape, right? So you guys know that from the formula that we have, I with respect to, for a rectangle with a base of B and a depth of H, right? I with respect to this axis, which we denoted as I bar, is 112 BH cubed. That's a formula. And then also parallel axis equation says, okay, if you want to move your axis to a new axis, so let's say you want to find I with respect to this axis. Actually, I can color code it. See, this is the yellow axis as it shown here. And then if you want to find I with respect to the blue axis now, right? I with respect to this axis, the formula says, the parallel axis equation says, you want to find I with respect to the blue axis, use the I bar and then do AD squared. Where D is the distance between the two axes. This is known as the parallel axis theorem, actually. Just in case you don't know, you can go and review this. All right, so let's do it for this piece. Let's call this piece number 1, call this piece number 2. Remember, we are subtracting them, right? So I, for piece number 1, with respect to the blue axis is I bar, which is the yellow axis plus AD squared. By the way, the distances are what? Here is 1 inch, right? Because 3 and 4, right? And what is it here? 2.5 to 4, this is 1.5 inch, right? If you look at the dimensions that we have here. All right, so here we go. I1 is equal to 112 BH cubed, right? That's I bar, right? This guy, plus AD squared. So let's go ahead. 112, B is 10, H is 6, right? That's with respect to the blue, yellow axis, plus area, which is 60, right? And the distance D is 1. So if you do the calculation, this I1 becomes, I believe, 240, and the unit, it should be inches to the power 4. That's a unit of moment of inertia. Dimension is length to power 4. All right, what about I2, the second piece that we're going to subtract? Again, that's also I bar plus AD squared. That is again 112 BH cubed plus AD squared. Of course, B and H are different, A and D are different. So 112, B is 8, H is 5, right? Plus area 5 by 8, 40. And this distance is 1.5 inches squared. If you do the calculation for this guy, I2 happens to be 173 and a third inches to the power 4. Therefore, I, with respect to this blue axis, this one, which is really the neutral axis, is the difference of these two, 240 minus 173.33. So that happens to be 67.33. Remember, this is the moment of inertia that is later on when you say you want to find bending a stress, and you use the flexure formula. This is the I that is going to be used in that equation. All right, guys. So I hope you enjoyed this video. And I will post this on YouTube, and I'll see you soon. Thank you for watching and listening, and see you soon.